Myself A. Kumaravadi Velan, Assistant Professor, Department of Computer Science, PG Department, GT Arts College, Autonomous Dindikal. Today we are going to see about the topic is double hashing. So this is the function. So under the open addressing method in hashing methodology. So before the double hashing method, there is two methods. One is a linear probing, another one is a quadratic probing. So this is the third one under the open addressing method. Next, so what is a double hashing? So double hashing is a computer programming technique used in conjunction with the open addressing in hash tables to resolve the cache collisions by using the secondary hash of the key as an offset when collision occurs. So what is a collision? So when we are going to insert an element in the hash table, so if you are inserting an element already in the hash table, so another element also can be inserted in the same location. That is called a collision. So this type of process, we are using the two hash functions in the double hashing method. So double hashing with the open addressing is a classical data structure on a table. So in this particular point, we have to know about what is a double. So double means two. Here we are using the two hash functions. So this is a very, very important point. So in this example we can see, so the double hashing by we are using the division method, then the table size is 10, that is m is equal to 10. The first hash function is 2k plus 3, then second hash function is 3k plus 1. So in this particular point, k means as a key element. The key elements are under the set A 3, 2, 9, 6, 11, 13, 7 and 12. So now we are going to insert an key element into the hash table. Okay. In this particular point, you have to know about the formula how the values are inserted into the hash table. So the kith element. So the kith element in the sense, the I in the sense is equal to 0 to m minus 1. So the values are inserted in the location by u plus v into I modulus m. Here the modulus m in the sense the remainder value of an expression. The expression is u plus v into I, where for example here the u is equal to the first hash function h1 of k modulus m, that is 2k plus 3 modulus m. Then v is equal to the second hash function h2 of k modulus m, that is a 3k plus 1 mod m. So these are the two hash functions involved in the double hashing method in this example. So in this example we are going to insert elements are 3, 2, 9, 6, 11, 13, 7 and 12. So totally we are going to insert 8 elements in the hash table with the size 10. So next, so this is a table to represent how the values are inserted into the hash table. So first the key element is 3. That involve the first hash function u 2k plus 3 modulus of 10. So here 3 value 2 into 3 as a 6 plus 3 9 modulus 10. Obviously we have a 9 value. So the process is, so this is empty. So the hash table is empty. So we can insert an element easily to the location 9. In the location 9 we can insert the value 3. So similarly we can calculate for 2 into 2 4 plus 3 7 modulus 10. So this is a percentage symbol represent the modulus operation. So you can get the value 7. Similarly the insert the number 2, the key element can be inserted in the location 7. Then 9. So 2 into 9 18 plus 3 21 modulus 10 the value 1. The 9 the element is insert in the location 1. Similarly the 6 is also calculated by the value 15 modulus 10, the value is 5. The 6 is inserted in the location 5. So next we are moving to 11. So in this particular point, we can elaborately see the how the double hashing function is involved in the successful manner. So first you are calculating the value 5. So that is 2 into 11 is 22 plus 3 25. 25 more or less 10 is the value is 5. So the 5 is already exit. So this particular point the collision occurred. In this particular point the collision occurred. Then next we are moving with the v value, that is 3k plus 1 more or less 10. The value involved here is 11. 3 into 11 is 33 plus 1 34. The value will be 4. So now we are calculating the value at ith position is equal to 0. If I is equal to 0, 5 plus 4 into 0, then 5 more or less 10 is equal to 5 again already exist, the collision occur. We cannot insert the element at position 5. The next value will be I is equal to 1. In this particular point 5 plus 4 is 9. The 9 is also already exit in the hash table. We cannot insert element 11 into the position 9. Next we are moving to the 2. The value is I is equal to 2. In this particular point 5 plus 8, the value is 13. So 13 more or less 10 is 3. 13 more or less 10 is 3. So now the place 3 is free. The location 3 is free. So now we are going to insert an element, the 11 in the location 3. Next we are moving to the element 13. So in this particular point, this is a special case in this example. 2 into 13 plus 3, that is a 29 more or less 10 is a 9. So 9 is already exist, the collision occur. Now we are moving to the calculate the value v. So the v value will be 40 more or less 10, that is equal to 0. So in this particular point v is equal to 0. If the v value is equal to 0, in this expression u plus v into I, the v into I part will be the 0. So u is equal to u plus v into I is equal to u only. So in this particular point we can calculate the value for I is equal to 0 to 9. The second part will be the 0 1. Okay. So this particular point we cannot insert an element 13 into the hash table. This is one of the drawback in the double hashing. So in this particular point, so we can move the rehashing method. So that particular topic will be discussed in later. So now in this particular point we cannot insert an element 13. This is the point here. The next we are moving with the value 7. So the key element 7, this is a very special case since the first element is 7. The 7 is already exist. The 7, the index value is already exist. So we are moving to the value, calculate the value v. The v value is equal to 2. So in this particular point, in all cases I is equal to 0, the value will be 7 already exist. Then I is equal to 1, you can calculate the value. So 7 plus 0 7, then 7 plus 2 9, then 7 plus 4 11, 1 already exist. Then 7 plus 6 13, 3 already exist. Then 7 plus 8 15, 5 already exist. Like that you can calculate the value from 0 to 9. You cannot insert an element in any location. So this particular pass repeatedly. So the 7 is also not inserted into a hash table. This is a very special case. 7 and 13 are the special case in this example. We cannot insert an element into the double hashing method in this example. Okay. Then the last element is 12. So in this particular point you can easily insert by calculating the u and v. So now we are moving to the calculate the location at I is equal to 0. That is u. Here u value will be 7. So already exists. Then you are calculating the value for v. That is 3 into 12 plus 1. 3 into 12 36 plus 1 37 more or less 10. That is 7. So plus v into I more or less 10. So 7 plus 0 is 7 already exists. Then 7 plus 7 into 1 7 14 more or less 10. That is a 4. Okay, that is a 4. The location 4 is free. So we can easily insert an element 12. So now we are conclude with how the values or the key elements are inserted in the hash table in the form of at the position 0 there is no element inserted, then at position 1 9 2 no element, then 3 11, at position 4 12 the last value, then 5 6, then 6th position nil, then 7th position 2, then 8th position nil, then 9th position 3. So totally out of 8 elements we are inserting only 6 elements. Okay, so this is the final state of the hash table after the double hashing method involved. Here the double hash involved with the table size is at 10, so the index value started with the 0 to 9 only. So these are the key element inserted in the hash table. So this is a simple example to explain the double hashing. If you have any doubt, you can give it in the chat box or any comments in this video. Okay, thank you for watching this video. So thank you so much.